Hey, welcome back. Today we are taking a look at this trading system and some of the decisions that it's making that I'm playing with and kind of just giving an update about what's on my mind. So in the past week, it's been a really kind of just practical turn for working on this system in that haven't gone really deep on improving the predictions so much as I've been looking at the internals of how data kind of flows from each step of the process, and I'm really trying to invest some time into making sure that I've got the foundations and the basics of how that data goes from one place to another really rock solid and automated, so that moving forward, as this thing kind of scales up in complexity, a lot less time has to go into manually generating certain things, or even if something's automated to some extent, having to do the tedious little manual pieces. Even if it's automated 80% of the way, I'm still kind of manually doing 20% of that. And so trying to push as much of that stuff into the automation spectrum as possible. Maybe we'll touch on that a bit. But first, just wanted to point out, for the little time I did put into trying to tweak the predictions, something that's really been kind of paying dividends, so to speak, is addressing some of these hyperparameters for the XGBoost model, the XGBoost classifier that are really aimed at avoiding overfitting. And what you're going to find if you're trying to build a trading system on something like this, you're going to be very vulnerable to overfitting, especially if you're just training on one symbol, which I am not doing. I don't recommend doing that. What I'm doing is kind of collecting a pool of data that goes for like many different symbols. Here, these are only the few that I've been looking at predictions for recently, but if we look at all of the different symbols that we're playing with here, we have basically every symbol that you have on the Gemini exchange. Now, I am getting a little bit choosy about what data I use. Like, for example, right now, I just want to focus on making predictions for things that are in US currency, US dollar currency. So I'm not really going to be, for example, looking at patterns that you'd see for comparing two different crypto tokens like Basic Attention token and Ethereum. If we look at this, maybe the trends might seem a little bit like they're relevant to a US dollar, but I've found that a lot of times when you pair some of these tokens against other tokens, you get some really wonky kind of patterns. Like, even looking at the close price itself here, you can see this almost like step function type behavior. And so in this, what the hell is this? This looks like it's like an ocean wave. And so when we're talking about building a machine learning system that's trying to learn patterns and then apply them to future decisions, if you have patterns that you're putting into the training data that aren't representative of what you're going to actually be making predictions on, that's bad. And so I'm avoiding this kind of thing, and instead I'd say, hey, Basic Attention token and Ethereum, these are both good to train on, but I really just want to look at data for like this BATUSD. If I'm going to be using the Basic Attention token's data to train my model, I want to look at something that's a bit more like this, where you see, okay, the step function type trends in the price, the actual price. By the way, this really kind of grayed outline in the background, that's the actual price. And this kind of orange and blue thicker line is a smoothed, it's that same price, but with a smoothing function applied. In any case, this is a lot more representative of the actual data we're going to be making predictions on. So we went down a little rabbit hole there, but going back to what we were looking at here with this, I've been tweaking these parameters and I'm trying to avoid overfitting. And that whole rabbit hole we just went down was about, you want to train on many symbols so that you can pick up patterns, not just for the one you want to make predictions on. And in my case, I actually train the model on everything that isn't the symbol I'm making a prediction for, just to go that extra mile to avoid overfitting. even then, a lot of these symbols and tokens are highly correlated to one another. And so what you really want to do to avoid overfitting is, first of all, or at least what I'm trying to do, is I'm trying to find these hyperparameters that are going to give me a tree model that doesn't convince itself it's got it right. So something that I've been taking a good long look at, if we scroll down here, is making the most of these. So what these parameters down here are doing is you're basically telling the XGBoost model that you want to not use the entire sample of data while you're training. Anyone who knows the basics of machine learning knows that in general with a model, you're going to want to train on your training set and then your testing set, and you have a validation set and blah, blah, blah. And maybe you do this train test split where you have 70% of your data goes in the training sample. And then 30% of that data is just the model's never trained on, and you use that to evaluate how things are going. And in this case here, we're even telling the model, we're going a bit further than that. We're saying while you're training, first of all, I might even want all these different trees that are being used in these models. Like if you set a parameter, number of estimators and whatnot, your model's going to be building different trees that are kind of traversing this decision-making process and seeing, which of these decisions come up with favorable trees that are building our forests, so to speak. And which of them lead to really bad conclusions, and what can we learn from this? And so something that we're doing here is we're limiting the amount of rows, limiting the number of columns, so the number of features that any given tree has access to. And the way you can kind of think about this, the way I think about it at least, is that if I have a whole basket of features and I'm just throwing that same basket of features at my model every time, maybe it's better if instead of throwing the entire basket, maybe I say, hey, why don't you just look at, instead of all 100 features, why don't you look at 60 of these? And this other tree is going to get a different basket of 60. It's kind of like divide and conquer. If I give you a small subset of all of these features, can you build me trees that are going to come up with a concept of, this set of features is really getting us the closest to the right answer, and then maybe some other portion of the model is working on a different subset of features, and it comes to the same same conclusion independently. Like, this feature is very important. I'd rather have that kind of thing going on than just throwing all the features all at once and then saying, all right, what did we come up with, and just having a one-shot answer. So then you have the same concept here, but by level. So there's another parameter in random forest and XGBoost models where you can control the depth at which the trees grow, and you could set this to like 6 or 4 or 10, and that's just going to say that no matter what, we're only going to ever at most go down to a depth of whatever that cutoff is. And now what you're doing with this parameter is you're saying by level, you're going to sample again. You're going to subsample the columns that were available at the decision point previously. You're kind of further restricting yourself to say, okay, we've hit a new level of this of the staircase that we're going down. Let's make it even more strict in terms of what basket of features we have to make a decision at this point. And that kind of helps you when you have a situation like a XGBoost model where we have maybe 5,000 different estimators, and you can kind of see like, oh, okay, we're limiting this sample for this particular estimator, but there's going to be another estimator that's going to encounter that same decision point, and it's going to have a different basket of things, and you can kind of learn from this, having different things that factor into the decision and seeing what the outcomes of those decisions are. So anyways, I'm on my preacher box here again about this, but this is something I've found introducing these hyperparameters and tweaking them has been very important in changing the behavior and changing the nature of the decisions this thing's making. Also, something that factors in quite a bit is this. So when you have unbalanced data, which we do when we're trying to predict this kind of this scenario where we have a lot of different points of interest maybe, and we're manually labeling like, hey model, this is a point of interest that we want to buy, but this isn't. Right now, we're kind of looking at some outputs from, I've been trying to make the model a bit more aggressive in when it would buy, even though I don't really like how that's manifesting here, where it's buying on this downward slope. But in previous things, let's see if we look at like Ethereum maybe, we could see how, like, this is what I'm trying to combat here. We have, okay, so we just saw there were all these blue dots saying, yeah, let's buy. Now the model here, in this case, is saying, no, don't ever buy. And so, the thing that I'm trying to play around with here is saying, okay, we have a bit of unbalanced data maybe, like in the way I'm labeling this, the reason that the model without a good bit of tuning is saying, nope, never buy, it's because it's, almost like so many of the points that are labeled are saying, no, don't buy. So when you're kind of cherry picking data to say, this would have been a very nice place in my dream world, we would buy this. But then it's like, 50 different points of interest go by and you say no, 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 no to all of them until you find another sweet spot to buy. In this case, like all these points here are places where we'd be like, no, 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 don't buy, don't buy. Oh yeah, here you should buy. No, 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 no. And we kind of combat this issue of having unbalanced data by setting some rule-based decisions on the raw data. So like not all of the raw data, not all of these data points are coming in here in the first place, which kind of helps us because now our data is not as unbalanced. But you are still in this situation where, maybe here we see somewhere between 20 and 30 points. And maybe only like 6 of those are ones that I would actually say are attractive buy points. And so your data is unbalanced. And so that's where this parameter of scaling, how much those, those positive outcomes, like how are you going to multiply those by some kind of factor to say, okay, our data is unbalanced. Let's give the outcomes where we actually see that we wanted to buy, let's give those a little bit more weight in the model. Give them a little bit more oomph so that they have a voice in the voting process as well. Okay, so that's kind of what I wanted to talk about on the modeling side. I am also introducing, I said I wanted to do a bunch more on the automating everything I can to automate. Right now, the process of actually generating the data that I label is a little bit tedious. So early on, the way we would do this is we would set some kind of rule-based filters, even here within Tableau, and then highlight the data, those points of interest that we want to further label to say, like, okay, all of these are points of interest maybe for potential buy positions, but maybe I don't want to buy this one up here, so I'm going to label this one a no. And I do want to buy this one down here because this is right before a nice big surge in price. Or maybe I decide I don't want to buy this one because there's nothing without, hindsight's 2020, but without knowing after the fact that this thing surged up here, there's nothing to tell us that this would have been a good place to buy. So maybe if I'm trying to get inside the model's head and think, hey, are there kind of, some previous, historical signs that this would be a good place to buy? Maybe I look for something like this where the price is going down, then we hit the end of the bump and we want to buy. So all of that to say that when you highlight points of interest, and these points of interest in my case are just things that have been, we defined some kind of feature, some kind of basic feature that allows us to very quickly rule out, throw out 50% of the data to say, no, we would never want to buy in this situation. We never want to buy something that's up at the peak. We only want to buy the dips. And so we have some kind of feature or a couple of features that might get us really close to saying like, hey, usually when you see this pattern, we're near a dip. Now, is this a dip you want to buy? Do I necessarily want to buy this dip over here? I don't know. Maybe that dip's not big enough. And so then that's where we create even more features, and we have a model where we could just feed all these points of interest in, and we can say, hey, we've labeled these things as buy or don't buy. hey, Mr. Model, can you figure out for us if we can detect some patterns here on what's happening in the price before this point in time happens, so such that if we see this pattern again and we know that we are currently here, would a model be able to say, oh, we need to buy right now because we think that the price is going to go up? Okay, so now in terms of automating this, we're now moving away from this manual type stuff. And I've already moved it into a process where I have some code in like a Jupyter notebook, and it's querying the data from the REST API instead of having to manually push data from Tableau to some kind of file that I'm then going to label. But all of this stuff is still being executed manually by me in an IDE or in Jupyter. And eventually I want all this stuff to just be converted into the same kind of idea of how I collect this data in the first place. So the way I collect the data is I have a Google Cloud function running every night that's querying minute level data from the Gemini Exchange and then storing that into a BigQuery database. And I never have to do anything manually. It just does it for me. And I kind of want that to happen with this data as well, because if I'm manually generating files for data to label, you can imagine that maybe in 3 months, I want to go back and I want to label additional data, because ultimately the more data you have to train your model, the better your model is going to be in general. And so rather than having to manually go through and change symbols and change timeframes and say, hey, I want to regenerate these 1,000 files and let me manually change this thing in a loop and execute this, instead of me having to invest, 30 minutes one night, an hour, 5 hours throughout the week, let's say, to get the model back up to speed, get that training infrastructure back to like a modern point in time where I have all this stuff ready to label and everything. I might want to be able to just hit a button and have all the stuff, all those points in time that have passed since I last labeled all of my data sets. I might just want to append all of those missing time periods into certain files so that I can just, grab a beer, grab a glass of wine, and just scan through and say, oh, okay, I have 20 new data points of interest here that I could label for this thing, and it's going to make the model better. So that's what a lot of what I'm focusing on now, that infrastructure, the kind of taking all the code that might exist right now in a kind of half automated format, refactor that to where it's all just set into super clean pipelines that I can not only run locally in a completely automated fashion, but eventually just once the system is in a place that I want it to be, I can deploy it up into the cloud and it's just running up there without any manual intervention, and making my life as easy as possible, because there's still going to be manual things I need to do, like labeling the data. Since we are working on supervised learning here, I will need to come back over time and label stuff so that we're, like for example here, we don't see any data. Why is that? Like no points of interest here. This isn't because there aren't any points of interest. This is because the last time I ran all of these processes to collect, what are my local extrema, my mins, my maxes, blah, blah, blah. I did that about a month ago or maybe 5 weeks ago. And since then, I've just been working on the models and working on labeling data sets and whatnot. But I need to manually rerun that specific process in order to get these points of interest again. So anyways, that's what we're going to be doing for the next week or so. It's very practical, not super sexy in terms of figuring out how to make this better and how to make this better. Which, by the way, the sell side I feel like is a little bit easier than the buy side. Like here, it's kind of like I'm trying to close off a trade, and so on the sell side I can be a bit more aggressive and I can say, hey, anytime we see a peak, like this is a potential sell point, and now I'm just basically throwing out certain points where this gets it right here in this cluster. We wouldn't actually want to sell at these points, blah blah blah. But it's a little bit harder on the buy side, because if we make our system a little bit too greedy, like we see here, or sorry, not here. This is one that's still running on the conservative model. This is fine, but it's not really buying as frequently as I might want to see. So I'm really hoping that I'm going to be able to Where was that one we were looking at? The one where I had tested out the aggressive strategy. Here we go. This isn't going to do me any good if I'm running my model and then I hit this downward slope and the thing gets clogged up because it can only have so many trades open at a time. And now it's just sitting here in this holding pattern saying, hey, I bought all this crap, but there's no opportunity to sell it because the price is way down here. So yeah, still got to get this right, but I need to get the fundamentals down first. Big fan of getting the basics right. And once everything is kind of just automated and we can click a button and all of the grunt work gets done for us, then we can really shift focus and really fly on spending our putting our brain into that more academic space where we're figuring out, okay, what's the best way to tune these hyperparameters and what's the best way to make this thing make the right predictions. So I'm going to stop it there. Blabbed for long enough, and see you for the next update.